this video, we're going to take a look at relations and functions. This is going to be quite a bit of vocabulary, but also want you to see the representations of the different ways we can represent relations and functions. Now, if you want a copy of the note sheet, I'm going to be sure and put it in the description below so that you can download a copy for yourself and just take notes with me. But let's take a look at some of these representations. So a relation is simply a set of ordered pairs. So we're going to have x's and y's. You may have heard of that before, just like I've listed here in A. But I can take those ordered pairs and I can plot them on a graph. You'll remember that we have an x-axis and a y-axis that helps us to know how far to move over and how far to move up and down. So I could represent my ordered pairs on a graph. I could represent them in a mapping. I could tell you, here's the first coordinates, and then I could draw lines to show you, oh, 0 being the first coordinate gets mapped with or paired with -2 as the second coordinate. So you can see I drew a line there for the mapping portion. I also could represent them in a table. I could give you the set of x coordinates here in a chart and show you how they are paired with a set of y coordinates. And then the last way is to do it with an equation. I could say, okay, if x's are 0, 3, and 4, this is how you would find the y values. So all 5 of these are showing you the same relation. They're all representing them in different ways, whether as an ordered pair, a graph, a mapping, a table, or an equation. Now, the domain of a relation is the set of input values or the set of x values. So most of the time, those are going to come first. And the range is the set of output values, generally the y values. I like to remember them in alphabetical order. So domain comes first, just like x does, and range comes second, just like y does, alphabetical order. Now, if I look at the example here and I want to write the domain, I'm going to write you the x values. So I'm going to write 0. I'm just going to use a curly brace to show it. I'm going to put 0 and then 3 and then 4. Now, even though the x value of 0 repeated itself, I only wrote it one time. I didn't need to write it twice. The range values, I'm going to list the y values, the second values. So that's -2 and 2 and -1 and 1 and 0. See, friends, you could get them from the second coordinates in the ordered pairs. You could get them from this location in the mapping. You could get them from this location in the table. So a lot of different places I could get those values from, but I have to write them. Now, since none of them repeated, I needed every single one of them in that listing. All right, let's take a look at some more here. Next, a function is a special kind of relation. A function is a relation where the x values correspond to exactly one y values. But here's the easy shortcut version. None of the x coordinates are used more than once. So let's look at number 2 and ask ourselves, is it a function? So if any of the x values are used more than once, it doesn't get to be a function. Well, looky here at the first 2. I see that the 0 is used twice as the first coordinate. That means it's not a function. Look at 3. I'm going to look at those first coordinates. I'm going to circle them just so my eye will be drawn to them. That's only what I'm looking at. I'm looking at the 1, the 2, the 3, the 4 here. None of those x coordinates were used more than once. So this does get to be a function. Look at number 4 here. Notice that these are your x coordinates, and the 1 is being compared with the 3, and it's being paired with the 4. So this 1 is actually being used twice. Because it's being used twice, it doesn't get to be a function. Look at number 5 here. Look in your X column. Are any of the X's being repeated, being used more than once? No, they're not. And because they're not being used more than once, we get to be a function. So remember, a function is simply a special kind of relation where none of the X values get used more than once. Now, I showed you how to tell if it was a function, if you had an ordered pair, if you were looking at a mapping, or if you were looking at a table. So look at these at the bottom here. This helps us if we are given a graph. So if we're given a graph of the relation, we can use what's called the vertical line test to be able to tell whether it's a function or not. Now, the vertical line test says if you can draw a vertical line somewhere on the graph and it only touches the graph one time, then it's a function. So you can see here, I'm moving this vertical line around in all these different places, and I'm still only touching the graph one time. That means this is a function. Look at number 7, though. If I lay a vertical line right there, my vertical line is going to hit it here and here. It's going to hit it twice. That's why this one is not a function. What about on number 8? If I lay a vertical line anywhere on the graph, will it touch it twice? Well, if I lay the vertical line right here, it doesn't. It only touches it one time. But if I lay it right there, it's going to touch it twice. So again, this one is not a function. Remember, I said at the beginning of this video, this is a lot of vocabulary, okay? So we're talking about all the different ways to say things and all the different ways to test it. Let's look at number 9 here. We want to find the indicated value of f of x, okay? So if f of x is 5x minus 10, and we want f of 10, here's what this notation is saying. Sub 10 for x. So we're going to put in 10 for x in the equation, okay? So f of x, so f of 10, remember we're replacing x with 10. 5 times x now becomes 5 times 10 minus 1. Order of operations tells us to do 5 times 10 first. 5 times 10 is 50, minus 1 is 49. So f of 10 is 49. Scoot this over here so we can see a little better. There we go. All right, let's do that one more. So f of x now is 2x plus x to the second, and we want f of negative 3. So remember what that notation tells us? We're going to sub negative 3 for x. So let's put that into our equation. F of negative 3 now is 2 plus, now be real careful in this x to the second, it's going to be negative 3 to the second. I put it in parentheses because we're taking negative 3 to the second power. So order of operations, negative 3 to the second power is negative 3 times negative 3, which is positive 9. And so we end up with 2 plus 9, which is 11. So f of negative 3 is 11 there. This is called function notation here, okay? And you may have seen that with the f of x part. All right, let's talk about domain and range from a graph. Okay, so looking at number 11 here, I want to draw your attention to those arrows on the end. Those are important. Shows us that the graph continues to keep going. So if my domain is my x's, so I'm looking left to right here, I notice that my arrows tell me I'm going to keep going. So that means my domain is all real numbers. My range tells me it's going to continue to go up and down. That tells me my y values are also all real numbers. Is it a function? Remember our vertical line test? If I put a vertical line anywhere on this graph, it only touches it once. That means this is, yes, a function. Let's look at number 12 then. My domain, be real careful on this one. I want you to notice that one of those is a closed circle and one of these is an open circle. So let's talk domain. So what is the x value at this point? Notice I'm starting at the one on the left. So it's -1, -2, -3, -4, -5, -6. So this x value is -6. And this x value here would be 1, 2, 3, 4, 5, 6. Okay, so I know all of my domains stay between -6 and 6. So I'm going to put my x for my domain between them. Now this is an open circle, so I'm going to say x is between -6 but not included. This is a closed circle, so x is between -6 and 6 and included. So notice for a closed circle, I have to put the equal to underneath the inequality. Let's do the same thing for the range, okay? So now we're looking at y values. I'm going to start at the bottom. The y value here is just 1. The y value at the top would be 1, 2, 3, 4, 5, 6, 7, 8. So I know my y values stay between them. Now, when the y value is 1, there's a closed circle. So I got to have the equal to underneath it. And when the y value is 8, it's open. So I don't have the equal to underneath it. So that is my range. Now, is it a function? Well, go back to your vertical line test. If I put a vertical line anywhere on this graph, it's only going to touch it one time. So yes, it is a function. All right. 13. 13 is kind of my tricky one. I want you to be real careful with 13. Look at my domain. My furthest left one is over here, which is at -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. So it starts at -10. And I have all the x values. Even when there's an open circle, there's a closed one at that same x value. Okay, until we get here, which is at 1, 2, 3, 4, 5, 6. So my x's are between -10 and 6. Now at -10, it's closed. So I'll put an equal to. And at 6, it's open. So I'll put not an equal to underneath it. Okay, now the range is what gets a little tricky because you have this space where you don't have y values. In fact, you have only the y value of -2, then a y value of 0, then a y value of 2, and a y value of 4. So that one, we're actually going to have to list it. We're going to say, okay, we have a y value of -2, a y value of 0, a y value of 2, and a y value of 4. It's a little tricky to write that, okay? Is it a function? Yes, it actually is, because look, even when you think you might draw a vertical line, and I'm going to draw one, see how it passes through the closed circle, but then you have an open circle. So it still only touches it one time, so it's a yes. There. All right, just a few more examples here with all of this domain and range. I hope it is coming together for you and you're feeling much more comfortable with it. On number 14 here, we have y equals 3x minus 2. So I'm going to just make myself a little t-table. I'm going to choose some x values and I'm going to figure out what their y values are, and then I'm going to draw it. So if x is -1, in place of x, I'm going to put a -1. 3 times -1 would be -3. Minus 2 would be -5. Let me put in a 0 then. 3 times 0 is 0. Minus 2 gives me -2. 3 times 1 is 3. 3 minus 2 is 1. So let me plot these. -1, -5. So start in the middle, -1, and then -5. 2, 3, 4, 5. There we go. 0, -2, 0, -2, and then 1, 1. Okay. So this is a line. And so I'm going to draw a line. Just going to use a straight edge that I have here to draw my line. And it continues in both directions. Now we did an example like that with those arrows on the end to help us see that it continued going. And when it continues going in both directions, we remember that my domain is all real numbers. And my range is also all real numbers. And because I can draw a vertical line anywhere on this graph and only hit it once, then it is a function. Okay, let's look at 15 then. So I'm going to plot the points. So -3, 2. So start in the middle, go left 3, up 2. Then I'm going to go 3, -2. So I'm going to go right 3, down 2. 5, -1. I'm going to go right 5 and down 1. 4, 1. 1, 2, 4 to the right, 1 up. And -3, 4. So -3 and 4. Okay, so let's write the domain. This time we're going to list them. So I've got -3, 3, 5, and 4. And I already had the -3, so I don't have to write that. And then I'm going to write my range would be 2, -2, -1, 1, and 4. Now this one is not a function, because if I lay my vertical line right here, it's going to hit it twice. Also, we saw that the two x values of -3 repeated. And so that left us where we couldn't be a function. Okay, last one here. Y equals absolute value of x minus 1. So this one, again, I think it's beneficial if we make a t-table. By the way, I'm a huge fan of making a t-table. You just can plot some points really quickly and see what's going on with the graph. So let's put in -2 for x. So -2 minus 1 is -3. Then we do the absolute value, which is +3. Do -1 minus -1 is -2. Then take the absolute value, that's +2. 0 minus 1 is -1. Take the absolute value, +1. 1 minus 1, 0. 2 minus 1 is 1. Take the absolute value. Okay, so let's plot these. So -2, 3 would be here. -1, 2 would be here. 0, 1, 1, 0, 2, 1. So this is an absolute value graph, very characteristic, making a V shape here. Again, you can plot more points with the t-table if you want, so you can see it a little bit clearer. That classic V shape that we get with all absolute values. So my domain here, I want you to know, goes left and right, no restrictions whatsoever. So we get all real numbers. Okay, but my range is tricky because we do have those arrows, but we definitely have a low point. So I want you to see that the y value, the lowest y value is 0, and it goes up from there. So the way I say that is that y is greater than or equal to 0. Because it's included, that's why I have the equal to underneath it. So it's a solid circle. Now, is it a function? Yes, because I can draw my vertical line anywhere on the graph, and it only hits it once. So that's a yes. So I hope this helps you with our domain and range, our relations, our functions. We've talked about, like I said, a lot of vocabulary in this lesson, and I want you to hopefully feel comfortable in using all the different representations.